We are going to look at writing formulas of covalent compounds. Writing formulas of covalent compounds. And as I said, if you already understand this, don't feel obliged to stick around for the rest of the lesson because this is basically all we're doing, this and determining which kind of compound is which. So if we have a covalent compound, how do we know that it is a covalent compound? What is it made of? What are covalent compounds made of? What are covalent compounds made of? Yeah, absolutely. They are made of nonmetals. So you're going to have a nonmetal, and you're going to have another nonmetal. So you're going to look for two things that are on the right-hand side of the periodic table. And when we were naming covalent compounds, what did we use in the names? In the names of covalent compounds, we use something. Prefixes, yes. And if you have already memorized your prefixes, that is awesome. If you haven't memorized your prefixes, make yourself some flashcards on those prefixes. I notice that people are still messing up. These are really common ones, hepta and hexa. A couple ways of remembering that. Hexa has an X, just like 6 has an X, and the word hepta and the word 7 have the same number of letters. Okay, so that might be helpful. Okay, now because we use these prefixes and the prefix tell us the number, to write the formula, just let the prefixes tell you the numbers. So to write the formula of a covalent compound, let the prefixes tell you how many of each atom. Okay, so for example, if I had P4O7, oh, that's the formula. Uh, let's try another one. Disulfur tetroxide. Okay, disulfur means I have 2 sulfur. So I'm going to write S2. Tetraoxide or tetroxide, 4 oxides. So I'm going to write O4. And that's it. It doesn't get much easier than that, right? That's why we kind of leave this one till the end. It's nice to end with something that's not too complicated. Okay. And just be aware that if you have like something like carbon tribromide, if there is no prefix, how many? How many carbons do we have? Yeah, just one, because we leave mono off the first word. Because mono is left off the first word. Okay, so that would be 1 carbon, and we do not put the 1 down at the bottom. And we would have tribromide, so that would be 3 bromides. Okay, and I'm going to give you one last example because this is something that messes people up all the time. And this one is, let's say we had potassium dichromate. Okay, many people will see the di and they will think to chromium. And they'll write something like this, KCr2. No, no. Does anyone know where we would find dichromate? Yeah, it has that 8 ending. It is on the polyatomic ion chart. Okay, if you see that 8 ending, it must be a polyatomic ion, and so you're going to look on the chart. It's not two chromates. Dichromate is not two chromates. You're going to actually look under D for dichromate. So look under D. So let's go on our polyatomic ion chart. Okay, oops, I'm not erasing. There we go. Here we go. Under D, we have dichromate, and it is Cr2O72 minus. Whoops, that wasn't what I wanted to do. I wanted to go back here. No, here, there. Okay. So we have dichromate, which is Cr2O7 2 minus. It is an ion, and therefore this compound is ionic. If a compound is ionic, we write the formula not by looking at the prefixes, because there really aren't any. Even the dichromate isn't really a prefix, it's sort of just part of the dichromate name. We write the formula by balancing the charges. We write the formula of an ionic compound by balancing the charges. You'll hear me say that over and over again. Grade 11, I'm writing all over people's quizzes. Balance your charges, balance your charges, balance your charges. What does that mean? If we are balancing our charges, it means make the total positive charge equal the total negative charge. Okay, and if your total positive and total negative are equal, what that means is that you will have an overall charge, overall, which we also call a net charge, equals 0. Nature loves to have a 0 charge. It doesn't like an excess of charge. Okay, so we had potassium. Potassium is in column 1, so it has a +1 charge. The dichromate is -2. Those charges are not equal and opposite yet. We need to have a second K plus because now we have 1, 2 plus, and that balances out our 2 minus charge. Whoops, 2 minus. And if we take our 2 plus and we add it to our 2 minus, we're going to end up with a 0 charge. So that's what's meant by balancing the charges. Make sure your total positive is equal to your total negative. And you do that for what kind of compounds? Ionic compounds. And you know you have an ionic compound because it begins with a metal or ammonium. Okay, so that's really it. I mean, there's not much more to say. Look at the prefix, and then that's how many atoms you have. Watch out for dichromate because it might trick you with that little di there. Okay, let us go and look at our flow chart. This is attached both to the assignment and it is also attached, um, it's in the what do you call it, files section of Teams. Okay, oopsie, that's not what I wanted to do. Should have done this beforehand. Didn't think of it. Oopsie. There we go. Okay. So this is one of those things when I was talking about that test, or even if you're just writing your quizzes, you can study this, okay? So you're thinking to yourself, I need to write a formula. So what am I going to do? I'm going to look at that formula and say, does it have a metal or ammonium? If it does, then it is ionic. On the other hand, if I have a nonmetal and a nonmetal, that means it is covalent, another word for which is molecular. So really, you're looking at your first substance in that formula and saying, is it a metal or is it a nonmetal? If it's a metal, then it's ionic. If it's a nonmetal and it's not ammonium, then you have a molecular compound. So let's start with ionic compounds. You are going to find the charge of the cation. Second thing you're going to do is find the charge of the anion. And then you are going to, number 3, write the formula by, like we were just talking about, balancing those charges. Okay. You'll notice there's another method mentioned there. There's the crisscross and simplify method. I'm not going to teach that to you. It is on the second page of this document if you want to look at it yourself. I'm sure there are videos out there all over the place. Um, the problem with the crisscross and simplify method is that some people use it without understanding why it works. And anytime you do something without understanding why, it becomes harder to remember, it becomes harder to apply, it becomes harder to do, say, next year, as opposed to something that you understood, which would be easier to do next year. If you're just relying on some special formula or whatever to make it work, then people have a tendency to forget things like that. Okay, so how do you find the charge of your ions? Well, for the cation, you're either going to see a Roman numeral, that's your charge, or you're going to see the position on the periodic table, which we'll go and do again in a second, or you'll look on your table of common ions. Okay, now on our periodic table, here we go. La 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 la. Da 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 da. Da 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 da. Okay. You can write these charges on your table. However, memorizing it is as easy as 1, 2, 3. Remember, it's as easy as 1, 2, 3 because our charges are +1, +2, +3. That one's super easy. Look at that. Group 1, group 2, group 3, +1, +2, +3. Then we're going to go over to our other side of the periodic table, and we're going to start from the right and move to the left. And this one is not quite as easy because we need to skip the noble gases because the noble gases do not form ions. They are happy, they have full shells already. Do not form ions. Okay, and so but again, it's as easy as 1, 2, 3. In this case, it's -1, -2, -3. So that means that nitrogen and phosphorus are going to be -3, oxygen, sulfur, selenium are going to be -2, and fluorine, chlorine, bromine, iodine are going to be -1. What about these little weird ones at the bottom, tellurium and astatine and stuff? You can kind of apply those rules, but we don't use them very often, so it's not a big deal. Okay. Now, our last group, of course, the red zone, we use the Roman numerals to tell us the charge. but we have this one little sort of mini staircase in the middle of everything with silver, Ag, zinc, cadmium, aluminum, gallium, and indium. But once again, it's as easy as one, two, three. And look at this, there is one element in silver's column that is plus one. There are two elements in zinc's column, zinc and cadmium, that are plus two, and aluminum has one, two, three. Those are all plus three. So in order to balance the charges, you need to know the charges. How do you know the charges? Either a Roman numeral is going to tell you, or you're going to look at your periodic table and say, where is that element? If I know it's in, if I have chlorine, I know it is -1. If I have sulfur, I know it is -2. Okay, back to our flowchart. Ah, there you are. Okay, so find the charge of the cation, find the charge of the anion. Again, either it's going to be on the periodic table or it's going to be on your table of common ions, right? So for these ones, super easy. It's all just listed for you. If you have nitrate, it's -1. You know, not much to do there. Just look it up. Okay. Where was I? On the flowchart. That's where I was. Yeah. So find the charge of the cation. Find the charge of the anion. Write the formula by balancing the charges. Okay. And let's say that we had something like iron 3 hydroxide. Okay. Iron is Fe. I know its Roman numeral is 3, so it's 3 plus. And hydroxide, this is one I wanted to point out to you. A lot of people are confusing hydroxide and hydride. Hydroxide is OH minus. You'll notice that there is the oxygen in there, right? We've got hydroxide, and we also have the hydrogen in there, hydroxide. It's a hydrogen and an oxygen. That is different than the hydride ion, which is just H, not H plus, H minus. Sorry about that. There we go. So watch out for that one. That's a really common mistake for people to make. Okay. And then we have hydroxide, which is OH minus. It is a polyatomic ion, so we would look that up on the polyatomic ion chart. We need to balance our charges. We've got more positives, so we need to add more negatives. In fact, we'll have 3 of them because that'll give us -1, -2, -3. Okay, and you would write your formula, and maybe you go like this and you say FeOH. Whoops. It's hard for me to write it incorrectly. Maybe you write FeOH3 and you're like, yeah, done. Whew. I got 3 hydroxides and I got 1 iron. This is where you're going to come to the part where you check. Okay, after you've finished writing the formula, you are always going to check. And if you're looking at brackets, if you have more than one of a polyatomic ion, you have to use brackets. So if I look at this, I have more than one hydroxide, right? I have 3 times OH minus. And you'll notice that when I wrote the times, it was almost automatic for me to put the whole thing in brackets because I'm multiplying not only the hydrogen, but I'm also multiplying the oxygen. I don't just have 3 hydrogen, I also have 1, 2, 3 oxygen. So I need to make sure that this little 3 applies to both the oxygen and the hydrogen. So I have to put it in brackets. Okay. So check to see if you need to have brackets. If you have more than one of a polyatomic ion, then you need brackets. If you have only one, of a particular polyatomic ion, you're going to have no brackets. Sometimes people get a little confused by this, and I wish I'd phrased this differently on here. Maybe I'll go through and change this document a little bit. Because sometimes they'll look at a compound like ammonium nitrate, and they'll say, okay, I got NH4, and I got two polyatomic ions, so I'll put them in brackets, okay? Or sometimes I'll see things like NH4, NO3, or I'll see NH4, NO3, and that could just be because I haven't phrased my instructions properly. Uh-oh, that was supposed to erase, not move my screen everywhere. Erase. There we go. So none of these are correct because the function of the brackets is to allow us to multiply everything inside the brackets. And here we're not multiplying by anything. There's no subscript. Yeah? When we had our brackets here, we put them in because we needed to multiply this whole thing by 3. We needed to have 3 hydroxides. Over here, we only have 1 nitrate and we only have 1 ammonium. So our correct way of writing it would just be NH4, NO3, and there's no brackets. And sometimes that can be a little uncomfortable when you're first getting used to these compounds because you're like, well, where does my cation end and my anion start? As you go through it more and more, it will just become more familiar. Ammonium is such a common ion. You're going to start looking at it and being like, there's my cation, there's my anion. I just know it because you'll have done so many of them by the time you get to say grade 11 or 12. Okay? So do not use brackets if you have only one of a polyatomic ion. There needs to always be a subscript on the outside of the bracket. So let's say I had calcium nitrate, NO3, there. I've got a subscript on the outside of the bracket. And so yes, that was necessary. Okay, I did want to put that subscript there. Few other things that sometimes people do. Sometimes they will put a Roman numeral in the middle of a compound. That is a big no-no. Don't do that. Sometimes because you should be writing down the charges when you're figuring out the formula of the compound. You should be saying I have a K plus and I have a Cl minus. But you don't want to show those in your final formula, right? You don't want to see these. The overall compound itself is neutral. Okay. And then finally, subscripts go at the bottom. They go below the writing. Okay. Sub means below. A submarine goes under the, well, marine is like water, right? So submarines go under the water. They don't go above the water. All right. You also don't want to do this, Ba3, N2. This is one reason that the, what was I going to say? This is one reason. Do I post the recording of the whole lesson or just parts of lesson? Usually the whole lesson, sometimes I'll break it into parts. So what I might do is I might have like that little section on writing the test, and then I might have the section on writing covalent formulas, and then I might have the section on, what's the other thing I'm trying to say? Ooh, brain gone. On using the formula chart. Yeah, okay. In the quizzes that you've been doing, you have been writing the formulas like this because sadly, I have not yet found any quiz that will allow you to enter your responses with a subscript. Okay, there is one, but it doesn't allow for automatic marking, which makes me very unhappy because I don't have time to go and check everyone's and mark everything individually. It's enough to just go and put in comments for those of you who are getting things wrong. But don't actually do it like that when you're writing it. Okay, that would actually be wrong. Whew. Okay, we didn't talk about the covalent ones, but we just talked about those today. So you're just going to use the prefixes to figure out how many of each element. Don't forget to memorize your prefixes. If you have not yet done so, make yourself flashcards, okay, to memorize them. I know these seem like silly little things. You can do online flashcards, you can use like flashcards, anything like that.